We're very excited. So let Annika introduce herself, even though I'm going to go first since she's our new face. Annika, please say hello.
Can you hear me now?
Yes.
Wonderful. Then I share my excitement again to be here today. My name is Annika Jodicke. I'm a postdoc for pharmacoepidemiology at the University of Oxford. And together with Kristin and Danny, I'm working on a project on long COVID, which we're excited to introduce to you today.
Awesome. So I'm excited because today I'm coming to you as a graduate student wearing my DPhil hat, and I'm going to tell you a little bit about our journey for long COVID phenotyping, which is a piece of our project here. So in the context of our specific project at Endworms, we are looking to characterize long COVID using UK primary care data. We've been lucky to receive some funding to approach this. And we know that long COVID is of interest across the board. We're seeing this in the literature that lots of people are recovering, but not really recovering. And of course, to do anything sophisticated on studying vaccine efficacy, we really have to decide what constitutes this phenotype. So we're taking a two-pronged approach here. We are doing a systematic review in which we are scanning 6,500 titles and looking across the literature to understand what is the current state of this. There are some really great systematic reviews existing that we are building upon. So this is really a labor of love here just to kind of update our understanding through September so that we can be as contemporaneous as possible. But most importantly, we also really want to leverage the power of the phenotype library and OHDSI best practices and find a way to take advantage of the hard work that Asieh and Gautam and so many others are spearheading. But the journey to a long COVID phenotype is, as with everything in OHDSI, a bit circuitous. And we want to credit how it started. So we know the Columbia DBMI team back in March had one of the first preprints that was really OHDSI leaning, and you have your concept sets and your phenotypes. And we've also seen some work from the National COVID Cohort Collaborative, both in their own literature review using the human phenotype ontology to do an initial characterization of symptoms. And they recently have a preprint on a more kind of probabilistic approach. So there's a lot of work that is out there. And what we have found is that there is great documentation here from the WHO on a Delphi consensus that was released last month. And yes, I was like, is October still last month, guys? I can't even tell anymore. It feels like a long time ago. But what we've been able to do is actually look at the body of literature, look at what we inherited from the Columbia DBMI team, and be able to compare. And just last week, we started this discussion with the phenotype work group around a long COVID subgroup. And we are by no means done with this effort. It's going to take quite a bit of time. And this is really the fun and exciting part. So first, we just want to say thank you, Gautam and Asieh and Evan, for letting us co-opt their long COVID subgroup to help serve our needs. And we look forward to bringing this WHO Delphi consensus to life. How we plan to do that is through the community collaboration of the work group. And there are about 25 symptoms that we have to create phenotypes for. Some of them are already existing. We're also going to then create a composite phenotype for long COVID, anchoring with the COVID definition that the phenotype work group has been working on for the last few weeks. And then we look into doing the systematic process of network validation with interested sites. And shout out to Gautam and team for this awesome flow diagram that talks through exactly how that process works. We are by no means reinventing the wheel here. We're actually just going to follow best practice and work through that. So this is the big first kind of call for collaboration to say that this is a big work product that we are excited about. And we think it's going to be the foundation of many other things, which Annika will tell you about. And I will pass it over to Annika to speak to what happens once we create a long COVID phenotype.
Thank you, Kristin. Yeah, so as you all know, studying vaccine effectiveness in observational studies comes with a handful of challenges. Kristin, can you show the next slide, please? Thank you. And that includes, for instance, that people became eligible for vaccinations at different points in time because the vaccine rollout was a staggered approach. Also, there are differences in baseline characteristics between vaccinated and non-vaccinated people, and of course, population level confounding, such as local infection rates or the percentage of people who are already vaccinated, which can always affect the risk for catching COVID like in the first place. So the aim of this kind of second part of the study that we want to present today is to test if a proposed analysis that we would have to look at vaccine effectiveness here would adequately account for confounding. Next slide, please. How are we going to do that? The large phase 3 COVID RCTs found that in the first 10 to 12 days after vaccination, there is not yet a protective effect against COVID-19. So we will test if we can replicate this kind of null effect in observational data when we compare vaccinated and unvaccinated people using the study design that we plan for our vaccine effectiveness studies. We expect that we do not see a risk difference between these groups, and if we would see any protective vaccine effects, then we would say that this is likely due to be residual confounding and not because of the vaccine. Next slide, please. Our study design will be a series of 4 staggered cohort studies, and that is based on the staggered vaccine rollout in the United Kingdom. So, for instance, in our first study, people aged 75 and older who became eligible to receive their vaccine in January will comprise the population. And among these people, everyone who got their first vaccine dose in a certain time window, in that case in January, will be in the vaccinated group, and everybody else will be in the unvaccinated group. And then we look at the next cohort, which will be starting in February, when the people aged 65 and older became eligible for vaccination. And this goes on and on. I think one of the interesting things is in this study design is that we always include people from the previous study who were unvaccinated to the next study, as they may always have received their jab later, and then they can always contribute to the vaccinated group in the next study. And we're going to do this in a staggered approach. So at the last study, all people aged 18 years and older will be included. Next slide, please. For each study, we will estimate the relative risk for COVID-19 using Poisson regression and apply inverse propensity score weighing to account for confounding both on the person level and on the population level. And in addition, we will assess negative control outcomes to test for unmeasured confounding. Lastly, we will pool the effect estimates from the individual studies in meta-analysis in the case of low heterogeneity, of course. Next slide, please. Why do we need these, let's say, feasibility work? Once we have phenotypes for long COVID and we have a study design that adequately accounts for confounding, we can look at the main objective of this project that we got funding for, which is looking at vaccine effectiveness for long COVID. And we will assess vaccine effectiveness, both comparing vaccinated and unvaccinated people, but also looking at comparative effectiveness for different vaccine types. Next slide, please. And now I would like to echo Kristin in saying that we would be delighted to collaborate with you and potentially run this as a network study. We have a GitHub repository for the project. Kristin highlighted the phenotyping work group. And of course, you can always contact us via email. So thanks a lot for your interest and of course for the opportunity today to present our study. Thank you.
And I'll make one shout out, which is we are especially interested in our colleagues throughout Europe who have other primary care databases mapped to OMOP who may want to participate. We're interested in all data in the network, but in particular, we're looking for other analogs in similar care settings to our initial remit. And so I'm just going to make a call to my good friends that you're all important to us, but in particular, if you have primary care data in Europe, you're especially important to us.
Thank you, Kristin.